Okay, for the question C. If the system is in a static equilibrium, that means not move up, not move down. That means that the total force upwards equal to the total force downward, right? So that means that from the equation, we notice, from the diagram, we notice that just the R is upward, right? So the rest will be equal to downward, correct? So this means that I can say that the R total up, this means that the total upward force R is equal to 50 Newton plus with the 50 Newton plus with 200 Newton. So R will be equal to 300 Newton. As a result, normal reaction R is equal to 300 Newton. Okay, back. Okay, ladies and gentlemen, now I want you all try to solve the next question. Solve the question number 4 now. Okay, ladies and gentlemen, a uniform ladder AB of length 2.5 meter and the weight of 200 Newton lands against a smooth wall as shown in the diagram. So what is the question? Copy the diagram and show what the reaction are of the wall on the upper end A of the ladder and the normal reaction P and the frictional force F at the lower end B of the ladder. So first, I use this diagram. From here, where will be the R? That means that here the R will act on this direction. Okay, and let me see here. The normal reaction of P and the frictional force. Okay, so we have another two forces. where this is the P and this will be the F. Okay, ladies and gentlemen, this will be the normal reaction that on point A. This P is the normal reaction on point B. That means that normal reaction on A is A. Next, normal reaction on B is P. Get it? What is the normal reaction of the system? Okay, the normal reaction of the system will be, let's say this I use a capital R prime prime, for example. Okay, where will be the R? So R prime prime. So how to find the R? As we know that if the ladder is not moving, this means that they are in equilibrium. To find out the normal reaction of the system, if the ladder equilibrium. So what we need to do, I clean it here. So this means that now the difference will be this two. Okay. So what we need to do first, we draw all the, it's still, this one still in this direction. This one must in the same direction like that. This means that I extend it and make it longer. Like that. Okay. Where normal reaction on the B, on the floor. In this system, what will be the normal reaction on this floor? It must be passed through the, what is that, in this direction. Okay, so this means that at the point they meet each other. So look at here. Okay, if the point, if the system is in equilibrium, let's say this point, that means a force going down. This will be the wet. A force going down. This will be the R, A, right? And this will be a normal reaction. Prime of the system, which the object in equilibrium. So three forces will cause it in equilibrium. So how to get that R prime? This will be the R direction. This will be the R prime. So we need to find out until they meet the point here. Three of the forces in one point. So this will be the normal reaction of the system. Okay. Now, get it? Now we back to the question just now. Okay. Let's move to the words file. Let me share to the words file. Where is my words file? Here. RA is perpendicular to the wet. Okay. Yongwei, RA is not perpendicular to the wet. Okay. But the RA, okay, is not perpendicular to the wet, but it's perpendicular to the wall. Okay. If we wish to find out that this one, because the wet is against the wall, right? So it's against the wall. This means that the normal reaction will be in this direction, where it's 90 degree to the wall, but not 90 degree to the wet. Understand? Okay, the wet is always going down. So the wet is always going down. Okay, now we go to the words file. Let's say question. For A already, right? Okay, now for B. Is 200 Newton, where this is the RA, and this will be the, okay, let's say it is P, and this will be the frictional force F. The length of 2.5 Newton, and this is 2 meter height. So total torque, this means that convert the total force and the length should be in, let's say, if I make it like that, 2.5 meter, 2.5 meter, this means 2.5 meter length. There will be a weight of 200 Newton at the center. Here will be, should have an RA. Okay, so which is must convert it into 90 degree. And this will be the, okay, this will be the P. Okay, in the whole vertical component, which is 90 degree. Okay, so this means that, let's say I convert it to RY, R in the Y component. So what I can set that the total torque about the point B. Let me go through the question again, yeah. Okay, B, calculate the magnitude of R, P, and F. Okay, we choose at the point B. Let's say this is the point B, this is the point A, right? We choose from point B first. The distance will be 2. Okay. This one 2.5, right? if I convert, that means that you notice or not, this distance is equal to 2 meter, correct or not? Okay, 2 meter, that means that R 2.5. Let's say this will be the delta. Okay, if I cos delta or sin delta, I make it like that, sin delta. You see, if 2.5, I make it sin delta. That means that if 2.5 sin delta, let's say I get the real angle, actually it will be equal to 2 meter. 2.5 sin delta is equal to 2. Because once I convert it into, I resolve it into vertical component, it will be, okay, it will be delta. If not, if we try to solve it, that means that from the triangle, this is 2, this is 2.5, right? What is the delta? So if 2.5, that means sin delta is equal to 2 over 2.5. So can somebody help me to count what is the delta? How much of the angle? Two over 2.5 shift sin. I get that 53.13 degree. Okay. Now we look at here. If 2.5 sin 53.13 degree, is it equal to? Okay, correct, right? That means that if I set that this is RA, if I use RA, I use the concept like that from B. This is RA. What will be the distance? This will be 2 meter. Okay. Actually, this comes from 2.5 sin 53.13 degree. Okay. So now this means that first, total torque. About the point B, it will be R times with 2. Okay, so minus opposite direction. Okay, R is, okay, anti-clockwise. Normally, anti-clockwise is positive direction. Clockwise direction will be negative. Okay, so minus the other one is 200, right? 200 Newton is at the center. 200 Newton is at the center. Center is equal to how much? Okay. This one. Okay. Another one, we get that. Okay, from the question, they give us something else. The question also give us the length. Horizontal length is equal to how much? It's equal to 1.5 meter, right? So R cos delta will be equal to 1.5 meter. So from here, okay, minus how much? Minus the 200 times with 1.5 over 2. Because the width is at at the half. So this 1.5 divided by 2, that means that it will be 0.75. So it will be equal to 0 because static equilibrium. The ladder is not moving, static equilibrium. So from here, we get that R will be equal 150 over 2. We get that it will be 75 Newton. Or this one, if you use you find out the angle. Once you get the angle, you use R sin delta, R cos delta. That means it will be equal. That means that you see, if you use R times with, okay, R F R1 F sin delta, okay, minus with R2, that means that W sin delta equal to 0. At the end, you get that the R still equal to 75 Newton. So that means that here sin delta and everything already we convert into 2 meter and 1.5 meter. So given, so we straight use the information. 2. Resultant force in the vertical direction. Okay, in all the vertical direction. Okay, total upward force. Up, just P. Down is equal to how much? Down, just the weight only. So P equal to 200 Newton. Okay, way from the equation, here is going down, and this will be P. This is 200. And next, if we notice that there will be a force in this direction, right, at B, and this will be the R, right? Okay, so 3, resultant force in the horizontal direction. Just now is the resultant force. Okay, in the vertical direction and the horizontal direction, that means that total force to left equal to the total force to right. Okay, so total force to left is R equal to the total force to right. Right, okay, will be the F. So R is equal to the F. So how much is the F? The F, 75 equal to F, right? So F equal to 75 Newton, where we calculate just now. Okay, ada pelajar tanya tadi ya. Okay, baik, saya tunjukkan. just now like that, right? The triangle like that. Given that this is 2 meter, 1.5 meter, and this will be 2.5 meter, and there is a force of 200 Newton, and this will be the P, and this is the R. First, find out an angle. So we can use sin cos 10. Okay, now if I use 10 delta equal to 2 over 1.5, so what will be the 10? What will be the angle? 2 over 1.5, so shift 10. I get that still 53.13 degree. Okay, so now this is not in the horizontal and vertical direction, right? So what we can do, okay, to find the total moment, okay, equal total, okay, total anti-clockwise moment equal to the total clockwise moment if there is in static equilibrium. Okay, so total anti-clockwise moment, that will be the, let's say we start from A. You can choose from B, but we want to find the R. If we want to find the R, this means no point you start from the point A. This means that R times 0 becomes 0 already. So this means I choose another point. So if I choose from the point A, this means that it will be R times with 2.5. What is the, I make it into in horizontal, that means cos 53.13 degree will be equal to the, okay, total clockwise direction. That means that this is 200, right? It will be 200 times with 2.5 cos 53.13 degree. Okay, so R, we still get that it will be equal to 75 Newton. That's all. Okay. So this is how we use the concept of the resolution of the forces to solve the problems. The important things, torque is equal to RF, where the R and F are in the perpendicular to each other. Okay, ladies and gentlemen, that's all for the question, and that's all for today's lesson. Okay, so we stop here and then we continue again tomorrow. So is there any question? If there's no question, I stop here and thank you very much.